Good evening, students. So today we will see different types of electrodes. In the last class, we have seen what is electrode potential and what is EMF series. Okay, and we have given some introduction to reference electrode, standard hydrogen electrode, and calomel electrode, like that. So today we will see more of electrodes of different types. So I am Dr. R. Srinivasan from Freshman Engineering Chemistry Department, IARE. Okay, so we'll start seeing today's topic. Okay, reference electrodes. So what is meant by reference electrode? Electrode whose standard electrode potential is known and it is not changed over the course of the reaction under the given condition. It's called reference electrode. Saturated calomel electrode is a reference electrode. Okay. See, for example, we say the important general purpose secondary reference electrode is calomel electrode. Why it is called secondary reference? Because primary reference is always standard hydrogen electrode whose potential we taken as we have seen that as She, standard hydrogen electrode. So it is it contains mercury and mercury chloride and Hg paste, then saturated chloride solution and platinum wire for conductivity purpose, and then it is connected to a salt bridge to the other side of the electrode. This is the construction of calomel electrode. It is represented as mercury chloride Hg2Cl2, which is called mercury chloride is called calomel. Okay, and that's why it's called calomel electrode, and chloride ions from KCl. So basically, the value of standard reduction potential of calomel depends on the concentration of KCl. Okay, so when it is saturated, the electrode potential is 0.2422 volts, which normally we use it as a secondary reference electrode in many places. One normal means it's a normal calomel electrode whose potential increases with the decrease in concentration. Okay, this calomel electrode can act as either a cathode or anode, depending on the other side of the metal you are connecting with the calomel electrode. So when it acts as a cathode, this is the overall reaction of the cathode of cell. HgCl2 plus 2 electron gives 2 Hg plus 2 Cl minus. So here this 2 will get cancels out. So we write like this. When it behaves as anode, this is the thing. Okay. 2 Hg plus 2 Cl minus gives Hg2Cl2 plus 2 electron. Okay. So this is anodic oxidation. Here it is cathodic reduction. So what are the advantages of calomel electrode? It's simple to construct and easy to operate. The potential developed remains constant throughout the long time. The electrode potential doesn't vary with the temperature. These are all the important points why we say it's advantageous to use saturated calomel electrode. Okay. Next, so when you want to determine the standard electrode potential using calomel electrode, we have to connect the calomel electrode via voltmeter with the other electrode, and which is connected through a salt bridge, okay, between the two sides. So now this calomel electrode can act as an anode or cathode depending on the system with which it is attached. So here, and also it is indicated by a movement of the current, direction of the movement of the current. So here EMF of the cell measured from this cell constructed here is, here we have used zinc electrode and the platinum wire for conduction, and calomel electrode is connected. Okay. So here the EMF of the cell, normally EMF of the cell is measured by a here we have a potentiometer. Okay, potentiometer is used to measure the voltmeter, or potentiometer we say is used to measure the cell potential or cell EMF. Okay, So cell EMF of the cell is equal to E naught right minus of E naught left. So here E naught right means it's a reduction, left means oxidation. So zinc undergoes oxidation, calomel undergo reduction here. So we get zinc electrode as minus 0.76 volts, which is verified. We already know from the table, but here we got it through this connection. Okay. Another type of electrode which can act as a reference electrode, secondary reference electrode, is called silver chloride electrode, AgCl electrode. Okay, both are solids. The electrode vessel is fitted with a silver wire. For example, this is silver chloride electrode. This is the Ag wire. This is the Ag wire partially covered with AgCl. This is a porous plug here. And this is KCl with AgCl. Okay, KCl with AgCl solution. And okay, this is connected to the other system. The electrode vessel is fitted with the silver wire, which is shown here. The silver wire coated with a fine deposit of AgCl. Okay, okay. The reduction the electrode vessel is fitted with a silver wire coated with a fine deposit of AgCl, which is dipped into a solution containing 1 molar KCl. The reduction potential of AgCl electrode is found to be plus 0.223 volts. Application as a secondary reference electrode. Again, AgCl electrode can also act as a cathode or anode. When it acts as a cathode, this is the reaction. AgCl plus electron gives Ag plus Cl minus. Okay. When it behaves as an anode, this is the reaction. Ag plus Cl minus gives AgCl plus electron. Okay. So here also. Okay. Now, what is electrode concentration cell? It is a galvanic cell. Electrode concentration cell is a galvanic cell in which electrode and electrolyte present in both half cells are same, but only the concentration of electrode into which it is dipped will vary. See, for example, here we have shown for nickel electrode, which is connected to a voltmeter. Okay, and this is oxidation side, this is anode cathode side we have written. The concentration of Na2 plus here into which the nickel is dipped is 1 into 10 power minus 3 molar. Here it is 1 molar. So here the lower concentration normally acts as an anode. Lower concentration acts as an anode and higher concentration side normally acts as a cathode. So here the electrodes are same. Only even the Na2 plus ion salt solution is also same, only the concentration varies. One is lower and another one is higher. So this is an example of electrode concentration cell where the anode cathode electrode formation is due to the concentration difference. Okay. So according to Nernst equation, it is given as E is equal to E naught plus 2.303 RT by NF log concentration of Mn plus divided by M, or we can say M is equal to 1. So, your Nernst equation E is equal to E naught plus 0.0591 by N logarithmic to the concentration of Mn plus. So, we know that 2.303 RT by F is given by 0.0591. Okay. Next. We have seen electrode concentration cell. Now it is gas electrode concentration cell. If potential, for example, we know that in standard hydrogen electrode, we have pressure of hydrogen 1 atmosphere is bubbled through a H plus concentration solution. So potential of standard hydrogen electrode is 0 when concentration of H plus is 1 molar. So when you take 1 molar concentration of H plus ions and pass 1 atmosphere, okay, and pass 1 atmosphere pressure of the gas, pressure of hydrogen, then you get the electrode potential is considered to be 0 under standard conditions. And if the potential of hydrogen electrode varies with concentration of H plus and pressure of hydrogen gas according to Nernst equation. Normally, the pressure potential of hydrogen electrode varies with, if you change either the concentration of H plus or the pressure of the gas, the electrode potential varies. If you, under standard condition, if you use 1 atmospheric pressure of hydrogen and 1 molar H plus solution, then you can consider that as a standard condition, and E naught value is equal to considered as 0 volts for SH. Okay. Only if you consider standard condition, which is the pressure of hydrogen 1 atmosphere and 1 molar H plus concentration. Okay. Then Nernst equation is given by E is equal to E naught plus 2.303 RT by NF log concentration of H plus by pressure of hydrogen. If the concentration of H plus is taken as constant, then potential inversely vary with respect to pressure of hydrogen gas. If concentration of H plus is taken as constant, then potential varies inversely with pressure of hydrogen gas. So a galvanic cell can be obtained by combining two hydrogen electrodes with different pressure of hydrogen gas. For example, H2 of pressure P1 in interface with H plus ion. Then another one, H2 of pressure P2 in link with H plus ions. Okay, this is not a way to write. This side, we'll write directly pressure of 2. Okay. H2, another side, one side P1, another side P2, where P1 is greater than P2. Okay. So this is a way of writing gas electrode concentration cell. For example, hydrogen electrode, hydrogen gas electrode, we can write a cell like this, where the two hydrogen pressure on both the sides varies. Okay, next. So there are different types of single electrodes. We will see one by one. First is metal ion electrode. So this is nothing new. We have already seen different types of metal ion electrode. This is used as commonly as a construction of galvanic cell. We have seen zinc, copper, cadmium, mercury, like that. Okay. So metal ion electrode. Metal in, for example, zinc means zinc with Zn plus 2. Copper means copper 2 plus with copper. Cadmium means cadmium 2 plus with cadmium. Ag with Ag plus, like that. Okay, metal with metal ion electrodes. Okay, this is used in galvanic cells. We have seen that before in the last session. So this type of electrode, metal ion electrode, is commonly used in the construction of galvanic cell. So in this electrode, a metal is immersed in the ionic solution of its own salt. Okay, zinc in zinc sulfate, copper in copper sulfate, like that. It is represented as M plus N by M. The potential of this electrode is due to oxidation of metal to metal ion or reduction of metal ion to metal. Example, copper 2 plus. Okay. So the Nernst equation for this type of galvanic cell type of electrode is E is equal to E naught plus 2.303. E is equal to E naught plus, we can write 0.0591 by N, the logarithmic concentration of M, N plus. This is Nernst equation for this type of metal ion electrode. Okay. Next type is redox electrode. So redox electrode, the word itself says where the reaction undergoes both oxidation and reduction. So in this electrode, ions with chemical species in two different oxidation states are in contact with each other. An inert metal like platinum is used to pick up the potential resulting from the oxidation or reduction from one oxidation state to another oxidation state. For example, if you take iron Fe plus 2, ferrous. Iron, Fe plus 3, we call it ferric. Okay. So when ferric. So when ferrous oxidizes to ferric, okay. So when Fe plus 2 becomes Fe plus 3, there should it's oxidation. Then there should be something which should undergo reduction. That is happened with chromium K2Cr2O7, which is an oxidizing agent. Means it oxidizes the other species to get reduced itself. Okay. So platinum bar Fe2 plus Fe3 plus. See, this is the same example. We will do potentiometric titration in the laboratory. Okay, potentiometric titration in the lab, which will tell you amount of Fe ferrous ion in the solution. So Fe2 plus gives Fe3 plus electron. This is undergoing oxidation. The reduction is by Cr2O7, okay, minus 2 plus, okay, what is oxidation number here? 2x minus 14 is equal to minus 2, 2x is equal to plus 6. So plus 6 becoming plus 3 electron gives Cr3 plus. So this is undergoing reduction. Okay. So platinum is used in whenever you take the ferrous sulfate solution in a beaker, and then if you add the concentration of 0.1 molar or like that, 0.05 or concentration of K2Cr2O7 from the burette, and then the cells, the both end of the cell, one is like a calomel electrode and the platinum electrode, which is indicator electrode here, which is used as indicator electrode. Calomel electrode acts as a reference electrode. So both these electrodes are into the beaker, and both the other ends electrical connection is connected to a voltmeter. We will get with each addition of whenever you add, okay, whenever you add K2Cr2O7 to Fe2 plus, there will be some amount will be converted to Fe3 plus. Okay. So whenever you add K2Cr2O7 in droplets, Fe2 plus will convert to Fe3 plus, and corresponding change will be there in the potential, which will be shown by the potentiometer. So this type of changing the potential by adding the K2Cr2O7 to Fe2 plus is example of potentiometric titration. So Nernst equation for a redox electrode is E redox E plus is equal to E naught redox plus 0.0591 by N log oxidation state by reduction state. Okay. So this is how redox electrode. Next, gas electrode. We have already seen standard hydrogen electrode, primary reference electrode comes into the category of gas electrode. Okay, whose She is nothing but hydrogen 1 atmosphere, HCl 1 molar. Chlorine glass electrode is nothing but platinum, Cl2 glass, chloride ion aqueous. So this is the Nernst equation. Okay. Amalgam electrode. So in this electrode, this is the type of electrode which is used in the construction of electrode concentration cell. Okay. So in this electrode, a known concentration of metal dissolved in liquid mercury is in contact with the metal. So potential of this electrode is due to the oxidation of metal to its ion or reduction of metal ion to metal. An inert metal like platinum is used to pick up the potential. Example, lead mercury concentration bar lead plus 2 gives. is to zinc amalgam, lead amalgam in connection with lead plus 2 ions, and zinc amalgam with zinc plus 2 plus ions. Okay. So this is the Nernst equation for this type of amalgamation electrodes. Okay. Metal insoluble salt electrode is nothing but AgCl electrode, which is a type of secondary reference electrode. We have seen Ag in sparingly soluble salt, AgCl. Its secondary reference electrode, like a calomel electrode, is a metal insoluble electrode, metal insoluble salt electrode. Calomel electrode is also an example. The Nernst equation for a calomel electrode is given by E calomel electrode is EMF of calomel electrode is called E naught calomel electrode minus 2.303 RT by NF log chloride ion square. Okay, so this is the Nernst equation for next ion selective electrode, which is very important one in electrochemistry. Ion selective electrode. So this electrode is more selective. From the name itself, it says it is selective to some ions. Ion selective electrode. It's more selective towards a particular type of ion in the mixture of ions, and hence it is specifically used to measure the concentration of the particular ion. Okay. So we know in labs pH meter, in which you have glass electrode. Okay. You will have electrode combined. We also call it combined electrode, which is having a bulb in the lower portion like this. Okay, and then if you dip this into the solution, it will show you the pH of the solution. Okay, so this is pH meter. This glass electrode is nothing but a example of ion selective electrode, which selectively senses the H plus ion concentration based on the pH is measured. Okay. So it is an indicative electrode. Ion selective electrode is an indicative electrode, and it is not due to redox reaction. See, we have seen in redox electrode, the reaction is redox reaction. Here in ion selective electrode, it's an indicative electrode, and it is not due to redox reaction, but it is due to ion exchange between membrane and the solution. Okay, we will see more in coming slides. Example, as I told, glass pH electrode is more selective towards H plus ion and used to find pH of the solution. The potential of glass electrode is given by Nernst equation like this, where Eg is the standard electrode potential, whose value is given. Okay, there are ion selective electrode. Other examples are not only glass electrode for H plus ion, there are solid membranes for fluoride. Okay, fluoride ions is also there. Lanthanum trifluoride crystal mounted on europium trifluoride is used. For chloride ions, pellet of Ag2S and AgCl is used. Okay, so in ion selective electrodes, the electrodes which have the ability to develop potential for a certain specific ions without causing interferences from other ions present in the mixture. Okay, that is called ion selective electrodes. The principle of concentration cell is used in the construction of ion selective electrodes. We have seen what is meant by electrode concentration cell. So for glass membrane is used. The following membranes are used in the ion selective electrode. Glass membrane, I told her there will be a bulb, glass bulb like that will be immersed into the pH solution to know the value of pH. This portion is made up of special membranes. Okay, that's how it is finding the selectiveness of H plus ion. The following membranes are used in the ion selective electrodes. Glass membrane means glass electrode. Glass electrode is selective only for the measurement of H plus ion concentration. Solid state membrane for fluoride ions. Lanthanum fluoride crystal mounted on europium fluoride is used. For chloride ions, Ag2S and AgCl is used. Okay, we will continue this ion selective electrodes. Further details in the next session. Okay. With this, today session is over.
Like, share and subscribe. Hit the bell icon for more updates.